In this video, we're going to be talking about series and parallel circuits and how they interact with each other and what their purposes are. So far, we've looked at circuits that have one path for electricity to go, as well as a single switching device. The majority of the circuits you work with in HVAC will be more complex. Therefore, we must understand the two ways circuits are designed. A series circuit exists when the flow of electrons must pass through a series of components. Switches that control loads are wired in series with these loads. So if we have a load that's an electric motor, every switching device that controls that load is wired in series. It's a single path for electricity to flow. This is another example of a series circuit. Switch 1 is in series with switch 2, which is in series with B1 and B2. Single path for electricity to flow. Okay, switch 1 is in series with switch 2, series with B1 and B2. If any one of the components in this circuit is open or fails, the remainder of the system will not work. Loads in series split the source voltage based on their resistance. Neither B1 or B2 in the prior example will be getting full source voltage. So going back again, if either switch 1 or switch 2 is open, there's no path for electricity to flow. If B1 or B2 fails, there's no path for electricity to flow. And B1 and B2 are going to split that 120 volts. No load is going to get full source voltage. The amperage is the same through the entire circuit in a series circuit. The total resistance is the sum of all the individual components' resistance. In the HVAC industry, it's rare to see loads in series. It's very frequent to see switches in series. Both switches must be closed to provide a path for electricity. In a series circuit, any open that's a break in a circuit will cause the circuit not to work. So when you're troubleshooting a series circuit, you want to make sure all switches that you can close are closed. You check the voltage across the source. In this case, we have 120 volts, which is what we expect. Check the voltage across the first switch. We get 0 volts. Now, voltage across a closed switch is 0 because there's no difference in potential. Check the voltage from source to line side of switch 1. 0 volts, it's what I expect. Source side to load side of switch 1. 0 volts. Source to line side of switch 2, 0 volts. Everything's working there. Switch voltage source to load side of switch 2, 0 volts. All my switches are good. My wire between source and switch 2 is good. Source to line side of B1, 0 volts. Source to neutral side of B1. Now I'm getting less than 120 volts, but I'm getting more than 0. Is this normal? Yes, it actually is, because remember, loads in series split the source voltage. So 60 volts would be an acceptable number. Again, wire is good. I get the same 60 volts there. Get source to neutral side of B2, 120 volts. Is this good? Yeah. Now I'm going across both loads, so I've now added both voltages together. Get my 120 volts. Source to neutral side of a circuit, 120 volts. When troubleshooting a series circuit, if you get source voltage across any switching device, that switch is open. When troubleshooting a series circuit, if you get source voltage across a load and that load is not operating, the load is bad. In other words, if I would have gone back here and gotten 120 volts and my B1 is not lit, I have a bad load. The light bulb's burnt out. Okay. Now, parallel circuits are the most common circuit in the HVAC industry for loads. These are the circuits that do the work. All loads in a parallel circuit receive full source voltage. Parallel circuits exist when a circuit has more than one load, but none of the loads receive voltage from another load. So I have line 1 and neutral here, 120 volts. Okay, I have 120 volts all the way down here between line 1 and neutral. So my light bulb is sourced is L1 to neutral, fan motor L1 to neutral, compressor L1 to neutral, heater L1 to neutral. Every one of these loads is getting the full source voltage. If one load burns out or goes bad, the remaining loads will continue to operate. All loads get full source voltage. The total amperage of the circuit is the sum of all amperages of the loads. So to get the full amperage of the circuit, you add all the individual amperages together. So this is an example of one switch controlling two loads in parallel. Switch 1 is open. B1 and B2 are in parallel with each other. You see, they're next to each other, and they're both connected to L2. Two loads in parallel, each controlled by a switch. Okay, I'm bringing L1 into both switch 1 and switch 2. Either switch closes, the respective light bulb lights. This would be the parallel circuit is how room lights are done in your home. To troubleshoot a parallel circuit, it's the same basic procedure as a series circuit. We start at the source. Make sure all your switches that you could control are closed. So in this position, B1 and B2 should be energized. Use your meter and check and make sure that there's source. L1 to L2, 240 volts. I have source. Between L1 and the start of the branch, 0 volts. There shouldn't be a difference in potential there. We're fine. Okay, we want to check the wiring between the branch and switch 1. 0 volts, we're good. 0 volts, switch 1 is good. 0 volts, the wiring from switch 1 to B1 is good. Voltage across B1 is 240 volts. That is correct because each load in a series or in a parallel circuit gets full source voltage. So in this case, if B1 is not operational, okay, it's a bad light bulb or a bad load. Okay, and again, we're just checking connections all the way through. Okay, in this case, I have 240 volts across B2 from L1 to B2. If B2 is not operational, it means there's a bad load because it's getting voltage. Everything's fine. When troubleshooting a parallel circuit, if you get source voltage across any switching device, the switch is open. When troubleshooting a parallel circuit, if you get source voltage across a load and that load is not operating, the load is bad. Some general troubleshooting rules: start at the source and work your way from there. If you get any voltage across a switch, that switch is open. If you get voltage at a load and the load is not working, the load has failed. So what you're going to be doing if you're in a classroom listening to this or working with an instructor, you're going to build and check a series circuit using your meter. You're going to build and check a parallel circuit using your meter. And then make sure you get appropriate sign-offs and every person participates in the project.